Hey everyone, today we'll be doing the bottom view of a binary tree. It's basically it comes under the series of a binary tree that we are currently doing, and it's a medium level problem. Now what we have to do in this is like a tree will be given, and we have to if a viewer is seeing from the bottom of the tree, then which all are the nodes that it will be visible to him. Like if it he's viewing from this side, like this tree, so he will be able to see like 5, 10, 3, 3 as well, because it comes under a little slightly beside 10, 3, 14, 25. Okay, so this are the nodes that will be visible to him. So what we our intuition is like, how we'll be analyzing this problem. It's like we'll be just assuming like a root node that is there. It is at the zero line, imaginary line we'll assume, and whatever the node next to it that's left is available, it will be under a -1 line, and the next again the left is a -2 line. Okay, so we'll be giving like a number like 0, and then if it's going to the left then -1, and again it's going to the left then -1, so it will be -2 over here. And if it's right then +1, like it will be 1, 0 plus 1, and then if it's right then again 0 plus 1, so it will be 1 and 10 2. So, and these lines will be taking the last node that is available at that line. So at the -2 line, the last node is 5. At the -1 line, the last node is 10. And at the 0 line, this is the 0 line, it will be like a last node. This will be like if two nodes is present. Okay, so we'll be taking the next node. Okay, so 4 at the 0 line, it will be 4 that will be visible. Okay, and 3 will be a little bit overlapped by these two things. Okay, and the next node is like 1 at the position 1, like a 22 and 14 this line, so it will be 14 that will be visible. Then the next it's 2 line, the line number 2, that will be 25 that is visible. Okay, so this way we can give the bottom view of the binary tree. And coming to the example part, it's a very easy example that is given to us right now. At example 1, like what will be visible, like a 3, 1 and 2, so nothing is overlapping, it's just whatever the node is there, it will be visible as the bottom view. Okay, and coming to the example 2 as well, so here only one thing will be overlapped, like a 10 and 60, so that 60 will be visible since it's a last node of this imaginary line, that will be 0. Okay, so 0 and then 1 and -1, this type line we will be thinking of, and this will be 1. So 40, 20, 60 and 30 will be our bottom view. Now, coming to the problem solving approach, here we'll be taking up array list that we have to return. So first we will be just declaring it. So array list of integer, array list of integer, I'll give the name as a list, new array list, new array list, and then if my root, okay, if my root, this is the corner condition that we'll be checking, like if my root is null, then just return this list itself, no need to proceed forward with the other problems, so just return it over here itself. And for that for storing like the node with its imaginary line number, we'll be using a map. And to store like we have visited a node or not, we will take a queue. Okay, so we'll be taking a map integer, integer, here we'll be storing two values, like a map value, whatever the value is there, plus the line number in which it is stored. So it will be new hash map. Okay, new hash map, and then we'll be taking a queue of node. And Now in this you can see if we will see the problem statement that has been already predefined in this GFG. So the node is not only containing the data left and right, but it's also containing the horizontal distance HD. So we don't have to define another class and giving HD in conversion with the node. It's already defined. But in most of the case this HD will not be defined to us, only the node data left and right will be there. So in that case what we have to do another approach and define another class over here, combining a node and the value as a pair, and we'll be defining over here and then we'll be using it. So that approach we will be seeing in our next problem, that is top view of a binary tree. But here since we are doing the bottom view of a binary tree, in this it's already defined, so we'll be making use of that. If you want to see that approach, then you please go to my video of a top view of a binary tree. There I had explained a lot about how to define the horizontal distance uh, if it is not already predefined. Okay, so proceeding with the problem of bottom view of a binary tree. So node Q is the new linked list. Okay, and yes, we'll be moving, and first node that the root we are already know that it will be a 0. Okay, so we'll be just putting like a root dot hd. Okay, horizontal distance will be 0, and since we know we have visited this root node and we have put the value as 0, so we'll be putting it in our queue. Okay, so q dot add will be putting the root. Okay, and since we are putting the root because we have defined node over here. Okay, and here also we should keep node. Okay, now now we will be moving to while inside, and we'll be checking if my queue is not empty, then we will proceed. Okay, while not if q dot is empty. Okay, q dot is empty, then we will proceed. First we will take out the value, store it in temporary variable, and q dot ove remove it, and in hd just store like a temp dot hd value that will be 0, that we have only defined it. Okay, and now this is value is in q. Now we'll put in map, so map dot put I'll keep hd as my value key, and the value as my node value as my value of the hash map. Okay, so it will be temp dot data. I think so we should just check it if it's data or value. It's data over here, so we'll be using the data itself. Okay, okay, this map done, map it's done. So if for 0, okay, for 0 only I'll explain. Like, coming to the example 2, like for 0 comma value, it's coming like two times. First it will come like 10 and then 60, so this value will be overwritten. Okay, first 0 comma 10 value will be there in the map, and the next time it will be 0 comma 60. So at finally I'll be storing all the last value of each line. Okay, then we will be proceeding with my left and right values. Okay, if my temp dot left, okay, if it's not equal to null, then what we'll be doing is we'll keep first we will assign that hd value. Okay, uh, temp dot left. Okay, temp dot left dot hd, it will be like current hd minus 1, since it is left of it. Okay, and we will put the node to q. Okay, so q dot add temp dot left. Okay, now similarly we'll be checking for the right thing. Okay, if my temp dot right it's not equal to null, then we'll be just first we'll assign the value of hd value, horizontal distance value. So it will be temp dot right. Okay, and it will be hd that will be equal to hd, and since it is right, so plus 1. Okay, semicolon we should not forget over here, and add, and we'll be adding temp dot right. Okay, right value will be assigning, and yes, we'll be completing the while over here. And then we have to just in the queue map, hash map, the value and the key is already stored, so we'll just with the help of an entry set, we'll just traverse the map and get the value and store it in the array list. So just one function is left. So for map, we'll be using map.entry set, tr entry, map.entry, and integer comma integer and en. So here I want to explain the thing, like for traversing of the map, like this is a method of like traversing a map. So this should be n. Okay, map dot entry set, since it is like a map of integer comma integer, so I'll be putting like a map of map dot entry integer comma integer, and here we can give any name as our identifier. Okay, and this the second one will be like traversing in which map, so it will be our map name is map dot entry entry, and this will be capital S. Okay, entry entry is the same like a keyword, and this will be a capital S. And yes, this you need to just take care of. And yes, we'll be adding the values, okay, to the list. So list dot add, and we'll be using this en as our object to extract the value from the map. So en dot get value. Okay, en dot get value, and we will be capital, and this get value. Okay, so it will get value, and all the value will be stored in the list, and finally we'll be returning the list as our final. Okay, so yeah, done with all the things, and just we need to check with the test cases. It's taking a lot of time. Okay. 125, some error was there. Okay, this comma should not be there. Okay, now it should run. And by the time it's compiling, and we should just we'll go through the time and space complexity of this program. So it's not a, it's a order of since we are traversing like each node at least one times, so it this time complexity is order of n. And we are also using a space complexity like a queue like of n size, and a map of n size, so it will be like a order of n plus order of n for space, but we will be taking as a maximum, so space complexity will also be order of n. Okay, still it's a very slow network. I think it will compile because only one error was there when I was compiling it. Okay, so this will compile, and yeah, the similar thing like what we are doing for bottom view of a binary tree, the similar thing in a similar way, like we can do the top view of a binary tree as well. In the top view, we'll be just checking the all the first node of every horizontal line. So in that way we can do the top view of a binary tree. That video is also available in this channel, you can do check it out. And please do consider subscribing the channel, it just give a lot of motivation for uploading a lot of videos to you people. And yeah, just go through the programs, and you have any doubt, just put it in the comment section, and I'll try to reply for that. It's, I think it will compile now. It's taking a lot of time. Today my net is a bit slow, so I apologize for that. Oh my god, it's taking a lot of time. Oh my god. Just submit it once only. No need of compiling. Oh my god. Yeah, got it. Oh, what is it? Again it went off. Just try to change the network so that the speed gets better. Okay, now some compilation error is there. Just check it. Okay, okay, it's coming as a wrong input. Okay, I'll check it out. Like array list if node map of integer, okay, and q, okay, hd q dot add root, okay, empty, and temp dot hd map dot put temp dot data if left not equal to null, left hd it's equal to hd minus 1, temp dot left, and temp dot right not equal to null, temp dot h right hd is hd plus 1, right, map dot entry set at value, and I'll be putting like a tree map. Just check it with this, and yeah, it's coming. Yeah, I got the correct output. Actually, the problem with this is basically the hash map will allow the null values, but tree map will not allow the null key values. So I think that was the problem. It was not taking. So yeah, try it with the tree map and it'll be sure like it will be running. And do check out the top view of a binary tree as well, because it's a bit similar, but in that I have explained in a bit more elaborated way how to take this hd if it's not already given. So that will be helpful. And yeah, meet you in the next video. Till then, thank you.